Good morning. This is Dr. Sharna Mounty, Assistant Professor in Mathematics, Government First Grade College, Jeevargi, Gulbarga. In this video, we have to go for the one of the most important terms in Fourier series, that is half-range series. In that half-range series, we know that there are two terms, sine series and cosine series. What is this half range sine series and half range cosine series? Before going to that, we have some recapitulation of the Fourier series and definition of half range series. If a function is defined over half range, say 0 to L, instead of the full range from minus L to L, it may be expanded in a series of sine terms only or of cosine terms only. The series produced in the called a half range Fourier series. We then extend the definition to the other half in such a manner that the function becomes even or odd. What do you mean by the even and odd function of half range Fourier series? An even function can be extended using half its range from 0 to L, minus L to 0 or L to 2L. That is, the range of integration is L. The Fourier series of half range even function is given by f of x is equal to a naught divided by 2 plus summation n is equal to 1 to infinity a n cos n pi x divided by L, where a naught is equal to 2 divided by L integral 0 to L f of x dx and a n is equal to 2 divided by L integral 0 to L f of x cos n pi x divided by L into dx. In this even half range cosine series, the Fourier series does not contain the Bn values, so that Bn is equal to 0. If we come for the odd function, it can be extended using half its range from 0 to L, that is, the range of integration has the value L. The Fourier series of odd function is given as a naught is equal to 0 and a n is equal to 0 in the Fourier series function, so that the Fourier series can be written as or explained as f of x is equal to summation n is equal to 1 to infinity bn sin n pi x divided by L for n is equal to 1 to infinity. So if it is a bn, then its value is 2 divided by L integral 0 to L f of x sin n pi x divided by L into dx. In this video, we have the examples which is related to the even function, that is even half range function, or we can say that half range cosine series. In this example, we can say that half range cosine series for the function f of x is equal to 2x minus 1 in the interval 0 to L. So L is equal to 1 they are given. So for that, according to the cosine half range series, the function which contains only a naught and en. So the a naught and an, already we know the what the formula. According to that, the a naught is equal to 2 divided by L integral 0 to L f of x dx. F of x is 2x minus 1, and taking the integration, that is x square minus x over the interval 0 to 1 and a naught is equal to 0. In a similar manner, an is equal to 2 divided by L integral 0 to 1 f of x cos n pi x divided by L into dx. Here f of x is 2x minus 1, and taking the multiplication to the bracket, it goes an is equal to 2 divided by 2 integral 0 to 1 2x cos n pi x minus cos n pi x into dx. The first term of the an, which is explained in terms of the Bernoulli equation. So an is equal to 4 integral of 0 to 1 x cos n pi x dx minus 2 times of 0 to 1 cos n pi x into dx. So that is equal to 4 times of, using the Bernoulli equation to the first term, it will be x sin n pi x divided by n pi plus cos n pi x divided by n square pi square, which is running from 0 to 1. After for the second term, it is integration of cos is sin n pi x divided by the bracket term integration is n pi, which is also running from 0 to 1. Applying the upper limit as well as the lower limit, we will get it is 4 into sin n pi divided by n pi plus cos n pi divided by n square pi square minus 1 divided by n square pi square. So here the sin n pi value is we know that it is 0, and cos n pi is minus 1 to the power of n minus 1, because the first term is going to be 0 and second and third term, in that the denominator n square pi square is a common, so take it outside. The bracket term is minus 1 to the power of n minus 1. So the an value is as a 4 divided by n square pi square minus 1 to the power of n minus 1, and an value already we got, it is a 0 for n is equal to even. For the n is equal to odd, the an value is 4 divided by 1 square pi square minus 2 plus 4 divided by 3 square pi square minus 2 plus dash dash, and that value is minus 8 divided by pi square plus minus 8 divided by pi square 3 square plus dash dash. Therefore, the Fourier series of the given function, it is minus integration that is f of x is equal to summation n is equal to 1 to infinity 4 divided by n square pi square minus 1 to the power of n minus 1 into cos n pi x. Or otherwise we can substitute the value of the odd function what we got in the above, that is minus 8 by pi square is a common, take it outside, and the inner term is cos pi x plus 1 divided by 3 square cos 3 pi x. If we go for the second example of which is related to the cosine series, that is f of x is equal to x minus 1 whole square in between the limit 0 to L, so it means L is equal to 1, and according to that the Fourier series is this one, and a naught and an we can also define like this. For that a naught is 2 divided by L 0 to 1 f of x is my x minus 1 whole square into dx. Using the integration of x to the power of n, it is x to the power of n plus 1 divided by n plus 1 in between the range 0 to 1. Apply the upper limit and lower limit, we will get a naught is equal to 2 divided by 3. For the second term, that is a an, it is a 2 divided by L integral 0 to 1 f of x cos n pi x divided by L into dx. Substitute the value of f of x, it is x minus 1 whole square. So using the Bernoulli equation, we can expand the integral term. An is equal to 2 times of x minus 1 whole square sin n pi x divided by n pi plus 2 times of x minus 1 cos n pi x divided by n square pi square minus 2 times of sin n pi x divided by n cube pi cube 0 to 1. Substituting the terms, that is first term is going to be 0, and the second term it is 2 is taken outside, that is 4 divided by n square pi square into x minus 1 cos n pi x, which is running from 0 to 1, and the third term is also tending to 0 because sin n pi is 0. So the an value is 4 divided by n square pi square after substituting the upper limit as well as the lower limit. Therefore, the Fourier series is 1 divided by 3 plus summation n is equal to 1 to infinity 4 divided by n square pi square cos n pi x. And these are the some references that I used for making the video. Thank you.